Good morning, grade 8. So this is the rest of the lesson, what happens to energy during chemical reactions. As we know, energy doesn't end, so changes in energy are a part of all chemical reactions. Reactions can either release energy or absorb energy. The energy can be absorbed, we call these reactions endothermic reactions. So what is endothermic reaction? It is the energy taken in during an endothermic reaction is absorbed from the surroundings. Example for this is photosynthesis. As we know, photosynthesis is a process which the plant use to make their food. So they absorb the sunlight. We consider that this is the energy they absorb in order to release the food or the sugar they produce. And when we eat this sugar, we take the energy from it. So we call this endothermic because they use energy to produce products. Now, what about the energy can be released? We call these reactions exothermic reactions. The exothermic reactions can give off energy in several forms. For example, you feel warm and you feel warmth and see a glow when a candle burns. So burning is an example of exothermic. Let's see this question. List or name 3 everyday exothermic chemical reactions. First, we can say the car engine burning fuel. As we know, we need fuel to turn on the car. So the engine uses fuel. Okay, this gives off energy, which is the kinetic energy. And the match burning, the reactions occurring in pottery. We know that when we use pottery for example, lighting something, we take the light as an exothermic reaction. Now, energy is always conserved. The law of conservation of energy states that the energy cannot be created or destroyed. However, energy can change from form to another form. So the total amount of energy doesn't change in endothermic or exothermic reactions. For example, the light energy from the sun changes into energy stored in chemical bonds during photosynthesis. Now, what happens that, for example, when you use the oven in your kitchen, we know that the gas we use in the kitchen, it's methane, CH4. So this burns when it reacts with oxygen. And you know that if there was no oxygen, then there wouldn't be any burning. So this reaction produces carbon dioxide, okay, CO2, and water, H2O, as shown below. The reaction of methane and oxygen is exothermic. Now, burning methane releases energy as heat and light into the surroundings. This energy was first stored in the chemical bonds of the reaction. So the energy that was stored in the bonds of the reaction is equal to the energy released plus the energy stored in the bonds of the products. So the total amount of all the types of energy is the same before and after every chemical reaction. Let's see the question. Describe what happens to the energy absorbed during an endothermic reaction. The energy is stored in the bonds for the products. So it's the opposite of the exothermic. Now look at this stored energy of reactant. This between these molecules and the bonds of these molecules, we have something called stored energy, just like the battery, for example. Now equals the stored energy of a product and released energy. So this is the same amount of energy. Now let's see this question. Complete the Venn diagram to compare endothermic and exothermic. Now they both has something in common. Okay, look at the endothermic, releases energy to surroundings. The exothermic absorbed energy from surroundings. Both they conserve energy overall. Now, what about this? Now, what affects the rates of reactions? We have 4 main factors that increase or sometimes decrease. Here they mentioned the factors that increase the reaction. We have at the beginning something called the concentration. at higher concentration, okay, the reaction will be more. So the reactants, the volume of the reactants will be more, then the reaction will be more. So this is a positive relation. Surface area, when you increase the surface area, then the reaction will be more. Also the temperature, if you increase the temperature, the reaction will be more. Catalysts, just like the enzymes, okay, we use these substances, we add them to the reaction to increase the rate of the reaction, so we call them catalysts. Okay, this is the end of the lesson. Now you have to solve these questions, lesson review, so you will take a mark as a part of your second evaluation. Good luck, thank you.